Hi guys, welcome back. We're still sort of talking about the mechanical properties of materials. We were talking about the different properties and the different vocabulary we would use in describing how materials react when you push and pull them. Specifically next, we want to talk about some of the vocabulary words and some of the specific processes and tools we're going to use to actually test this inside the laboratory. As you know, this is a hybrid course, so we will have a chance in the laboratory to actually test our materials. We're going to be pushing and pulling them and flexing them and doing all kinds of things to them, but we want to make sure that we have the sort of the course and lecture stuff to back it up so that we can use the specific vocabulary to talk to these things. So let me push a few buttons here and we're back. Great. So this particular Prezi is entitled Mechanical Testing, and what we want to do is look at some of the vocabulary that we can use to describe how we're pushing and pulling these materials and then describe how they're behaving. So testing considerations wise, we have right out of the box we have three ways to consider how we're going to go about specifically pushing and pulling these things. The first thing is, how do we push it? How do we pull it? We could be pushing it two different ways. We could be pushing it along different parts of the particular piece that we're trying to look at. We could be pulling it, we could be twisting it, we could be bending it. All those different types of are how we apply the load. We also want to worry about the condition of the sample. Is it brand new? Did it just come off the manufacturing line? Do we want to test it that way? Has it been out there for a while? Is it under warranty? Have people been using it for a day, or have they been using it for a couple years? And we want to test to see how long our product lasts. So condition of sample has to be sort of a factor. Maybe for instance, this particular sample was accidentally dumped in a bucket of water, and then we dried it out, and now we're testing it. So it depends on how we want to deal with how we want to describe the condition. And then, of course, environmentally, all of these products are being used in a particular environment. We need to record and worry about various temperatures, humidity levels, pressure levels, especially these days. It's currently January when we're recording this. We just got through some really frigid temperatures here in Philadelphia. You can imagine that whether something bends or something breaks really depends on how cold it is outside. If you happen to smack something and it happens to be 7 degrees Fahrenheit like it was recently here in the morning, things have a tendency to crack pretty quickly. So when it comes to looking at load itself, there's some things we need to worry about load. Like one, what type of stress are we inducing? We talked about stress being a load or a force per unit area. It's sort of like pressure, but there are different types of stress beyond the simple idea of a push or a pull. We also can determine and be worried about how fast that stress is developed. Is it a very, very slow, little, gentle push that just gets stronger and stronger over time? Or is it a smack or a bang or a crash? Those that we use the term crash testing. You can imagine taking a really large, maybe a tractor, and driving up to the front of a car, and just very gently touching the nose of the car on the bumper and then pushing it back sort of a little bit at a time. You can imagine the car is going to respond differently than if we take a crash test machine, which has the weight of a tractor trailer, and the car is parked and all of a sudden we smack into it with crash test dummies inside. The materials are going to respond differently. The other thing we're going to worry about is, once we determine what type of stress and how fast we induce it, we have to worry about number of cycles. If the material happens to survive after doing once to it, so say we open and close a hinge, maybe we want to go ahead and cycle that hundreds of times, tens of times. Not so many now, but I remember back in the day, I mean really back in the day, one of the things we would do whenever we had a brand new school year is we'd go to the store and we'd buy all our notebooks and tablets and like. We'd also buy our pencils and pens, and then we'd buy a pencil or a pen holder or a case. And you could buy these pencil and pen cases with plastic hinges, or you could buy them with metal hinges or maybe even leather hinges. And if you have ever experienced using a little carrying case that has plastic hinges, after about 20 or 30 times of opening and closing this hinge, they definitely snap off. The same thing happens now if you happen to buy a plastic ketchup bottle. Not a glass bottle that happens to have a metal screw cap that you pull off. But a plastic ketchup bottle with a flip top lid, you'll notice that the flip top lid also has a plastic hinge. And maybe that flip top lid is good for 20, 30 openings, and then eventually the lid, the very top of the lid breaks off, mostly because it's not designed to last for 100,000 openings. The thought is by the time that you open the ketchup for the 100,000th time, you've already used all the ketchup inside of it, so there's no reason for them to go ahead and design that hinge to be anything more than just a piece of plastic using the same material that the cap is made out of.